Okay? So it's very important that we understand the problem. If we don't understand the problem, I think, are you guys, it's, hi, are you guys hearing me, or is it that the network is dropping?
So I
So I
think
think your
network is
network is dropping.
It's dropping.
Yes.
Okay, okay. Are you hearing me better now? Or-
No, for me it's still breaking up on my end.
All right, let me just, as I said, I'm here at Roy Tech because I don't have electricity at home today. So hence the reason. So I'm going back to the previous slide. I'm assuming you want me to go back to the average slide. So I'm looking at the average slide and I'm saying that the variables A, B, and C, summing them, and then getting the average that's what we do to output the average, the sum and the average. And then I looked at the example of the payroll example where we took the number of hours and the rate of pay, multiply the rate of pay by the number of hours, and we got the gross pay. And that was what we were able to do and be able to sum them so that we were able to get the gross pay. Any questions? Okay, so let's move on. Now, let me be clear. If what I will do, let me stop sharing and let's see if I can if stop sharing will help this for a little while. What I will do, I know, and I apologize for this because of Roy Tech's network. What I will do, I will do over this class because of the network failures, right? So we'll try our best to see how far we can reach today. And then on the next class, I will do it over and I am also supposed to do a makeup class for you guys. So my apologies for the network because as I said before, I'm working from Roy Tech today and then in San Fernando and their network is not that great. So that's one of the reasons we have once I'm at home because I have a very powerful network at home. So therefore we shouldn't have these problems going forward. But I apologize for this because of the fact that I don't have power today at home. So I have to come here to do the session. So we'll continue. And if anybody has any questions, we will we'll see. Okay. So somebody's saying you're not seeing the presentation. Okay, I've stopped it. Let me continue. Let me see. Are you seeing my presentation?
It's loading, sir. It's loading. Okay, never go. We can see it now.
You seeing the presentation?
Yes, sir. We are seeing the presentation.
Hello? Okay. You guys are seeing the presentation, right? Hello? Are you seeing the
no, sir.
presentation?
Oh my, now we're seeing it.
Huh? Are you guys seeing the presentation?
No, sir, not anymore.
Not anymore? Okay, let's.
It just came back up, so we can see. I can see it now. I don't know if anyone else can.
Hello?
Yeah, I can
Okay,
see it.
great.
Yes, so we can see it.
Everybody else can see it now, all right? Okay, good. Good. Right. Right, brilliant. Right. So that's where we are. So we talked about what's a program, we talked about average, we talked about payroll, we talked about how to solve a problem. Okay? How to solve a problem. We have different steps in solving a problem. We analyze the problem, right? In terms of inputs, outputs, we design the solution, we implement the solution, we test and debug, and we document the problem. That's the different ways in solving a problem. Okay? We analyze the problem, we design the solution, we input the problem, we implement the coding, we test the coding, and we document the problem. That's very important. When I give you a solution, that's what I'm expecting from you to solve. I give you a problem, and then we do this methodology. So therefore, there are different find the average, and we divide by 3 to get the average. Similarly, when we work on the payroll, we multiply the number of hours by the rate of pay, and we get the gross pay. So how do we solve a problem? We analyze the problem in terms of inputs, outputs, formulae, variables, constants. Step 2, we design the solution. Step 3, we implement. Step 4, we test and debug. And step 5, we document the program. Very important, all 5 stages. So I'll stop sharing now, right? And I'll make it a little bit more interactive. So what do we learn? What have we learned so far? We have learned that we have the ability to solve a problem. How do we solve a problem? We solve a problem by what? Defining 3 things. Anybody could tell me what the 3 things are? I'm just going to call on somebody so that you guys can, we try to make it as interactive. What are the 3 things that we, or even if you're not able to speak, put it in the chat, and I will then respond. What are the 3 things that we have in terms of to solve a problem? And again, I'm very sorry for the network issues, because that's a Reutech having a problem here. So what are the 3 things? I'll start. One is inputs. We need our inputs. If we don't have inputs, we can't solve the problem. Inputs are very important. And then what do we do with our inputs? Anybody? We take our inputs and we process the inputs. And then what we do, we produce our outputs. Right? Inputs, process, outputs. Basically, we take out when we have inputs, we refer to the inputs as what we call data. Data, once we have data, we then take data, we process that data, and we produce information, which is our outputs. And the information that we produce as outputs is used by businesses to make decisions. You guys follow that? So we talked about inputs, we talked about our program needed inputs, we talked about processing, and we talked about outputs. Any questions? Anybody has any questions? Okay. So what do? We take this information as this decisions. Let's now talk about if I give you a problem problem. Okay, if you don't understand the problem, you cannot solve the problem. That's the first thing. If you can't understand the problem, you cannot solve the problem. So you have to analyze, you have to understand the problem, you have to make sure that you know what's going on with the problem. Then the second step is to break that problem into simpler sub-problems. If you have a big problem, the best way to solve that problem from a technical point of view is to break that problem into sub-problems, into simpler problems. Okay? And then step 3 is to provide the code. Is after you provide the code, you then what? You then what? Test the code, and step 5, you implement. Okay, I see a few messages. Okay. Okay, any questions? All right, so let's just go back to the slides now and let's talk about where we are. Okay, so we're back to okay. So we're back to solving problems. So we analyze the problem in terms of inputs. I'm not sure what's happening here with why is it not loading? Okay, are you seeing my screen, guys?
It just came up.
Can somebody answer, please?
It just came up, sir.
Joel, could you answer? I'm assuming everybody.
Yeah, it just came up on our
So
end.
I think
Yeah,
there's a bit of a
yes,
delay as
sis,
well.
it's up.
Okay, great. Great. Right. So we analyze the problem in terms of inputs, outputs, formula, variables, constants. We design the solution. We implement the solution. We test and code, and we document the program. So that's very important. How to solve a computer program. We analyze, we design, we implement, we test, and we debug. Right? Those are the key steps in solving a. Right. Precisely. How do we precisely define the problem to be solved? Write the sequence specifications in terms. So there. And we have to look at any user. We talk about outputs. Any questions?
Sorry, sir, on my side, I'm barely hearing
Are
you.
you
It's
guys
breaking
seeing
up.
the slide with analyzing the problem? Can you repeat that? Okay. Are
I'm
you guys seeing the slide with analyze the problem?
On my end, I'm seeing the 5 steps. Okay, analyze the problem just came up.
Five. Are you seeing 5? What are you seeing? Are you seeing analyze the problem?
So
Anybody
we
seeing
know seeing
analyze the
Yes,
it.
sir, it
problem?
just came
We're
up.
seeing it.
It just came up on my end.
Oh, it just came up. Analyze the problem. Okay. It seems that the network, I said, is very slow. So my apologies for that. Right? Everybody seeing analyze the problem now?
Yes, sir.
Yes, sir.
Okay, great. Right. Thank you. So when we define the problem, we need to write the program specifications in the following terms. We need to look at processing. We need to look at outputs, and we need to look at interface, right? So it's important. So when we designing a solution, we need to look at inputs, processing, outputs, user interface. Any questions? Any questions, guys? With inputs, processing, outputs, right? So therefore, with
No, sir.
everything that you're doing, and this is critical, you need to look at inputs, outputs, process. Let's take an app that you use. The apps that you use is that you have access to the user interface. Okay? And behind that, there are inputs, there are processing, there is outputs for that particular app that you may be using. Any questions? Now, if you're having problems, just put a question. If you have a question, just put it in the chat now so I can be able to answer the question. Okay, so let's now move on. Right? So we have analyzed the problem. Then the next step is design the program, which is very important. How do we design the program? We design the program using different methodologies. We can use supports, we can use flowcharts, or we can use something called an IPO model. These are different methodologies that one could use to solve a problem by breaking the problem down into simpler sub-problems. Very important that we can solve a problem so you'll be given scenarios and you will be asked to either use an input-output model, you'll be asked to use a flowcharting model, or you will be asked to use pseudocode. So I'm going to just stop sharing again. And let's talk about methodologies. There are 3 methodologies. The 3 methodologies, and the first one we're going to look at is IPO, right? IPO refers to input, process, output. And I've been giving you many examples of input, process, output. Like, for example, the sum and average of 3 numbers, right? That example that I've used is an example of input-output processing. Where I input the 3 variables, A, B, C, D, A, B, C, I sum them, I divide by 3, and I get my output, right? And my output is my sum and my average, okay? Similarly, I gave you the example of payroll, where we multiply the number of hours by the rate of pay, and we get the gross pay. So the input is the number of hours, the rate of pay is the input, then the gross pay, which is the process, and the output is the gross pay. one we're going to is input, process, output. Then we look at pseudocode, and then we look at flowchart. So any problem problem. So whether I'll give you a few examples later on, like the area of a rectangle, etc. This is used to solve problems. Any questions? So let's just move on then. So designing, we talk about coding. The next stage is the code. After you have designed the code, remember at the beginning of the lecture, I said that 80% of writing a program is done off the computer and 20% is done on the computer, right? So therefore that 80-20 ratio is very important. 80% off the computer, 20% on the computer, okay? And that's important to note because most of our work is done off the computer. So what we do, we translate our design into an application, we write the program, we execute the program, and then we document the program. Okay, very important. With respect to coding of the program. So, and I just have one person answer. Are you seeing my screen with code the program?
So
Joel, are you seeing my screen with code the program? Huh?
Yes, sir. You hear me?
Okay, okay, great. So translate, so what we do, we translate the design in the application to the programming language. We write the program, we test the program, and then we make sure that the program is executing properly. And then we document. Anybody knows why we need to document a program? The reason we document a program is that the program may require changes. And if we don't document the program properly, who's coming, you may leave the job and somebody else replaces you, right? And if that person replaces you and there's no documentation of the program, what will happen is that the person may have may take a very long time understanding the program and take a very long time in terms of making changes to the program. So that's why the program has to be properly documented so that the new person who's coming in. Any questions? Any questions, people?
no, sir.
No, sir.
Okay, great, great. So very important. Let's take a step back, and I'm going to go back a little bit, right? So let's go back to the average question. Again, we're talking about inputs, we're talking about processing, we're talking about output. So that's the key, guys. In anything that you're doing with programming, you are going to be dealing with inputs, you're going to be dealing with processing, and you're going to be dealing with outputs, right? Inputs, processing, outputs. Very important. That's the Bible to programming. Once you understand that there what your inputs are, what your outputs are, and what your processing is going to be, and how you're going to get there. How you're going to get from inputs to output. What is the mathematics involved? What is the law? Something called logic, right? And let's have a little discussion on it, right? Now, any program that, if you're writing a computer program, the most important thing is to design how you get from your inputs to your outputs. outputs. Remember in the lecture, the data and your outputs is information. The information is used by the business to make decisions. Let me explain something to you guys, right? When you work in a business, you will understand technology is really a tool of management to make decisions. Okay. For a business. That is the function of information technology. Yeah? That's the function of program. Programs take data and generate information. The information is then used for decision making. So that's something that you need to understand as young modern programmers. You are using the computer as a tool to generate information for management to make decisions. That's very important. Okay? Any questions? Okay. So we continue now. We'll continue with respect to the stages in the development of in solving a particular problem. So let's continue. Right. So after we design the program and code the program, the next stage is to test the program and debug the program. Now, unless you are a very great programmer, right, you will not get this program working on the first try. The probability of it working on the first try is very, very, very remote, right? Unless you're an excellent programmer and you've been doing it for years, right? You tend to get errors. When the first cut, you're going to get errors. You're going to get different types of errors. The first type of error you're going to get most likely is a syntax error. A syntax error is an error. You use English to speak. Sometimes you may use green verbs or verbs that don't correlate to the subject. So therefore, your language overall or whatever programming language you're using, you're going to get syntax errors, right? And syntax errors is going to be the first order of the day. When you get syntax errors, you have to fix those syntax errors. Okay? Then you get something called, and I'll go to runtime, or what we call execution errors. Right? And then you get the other type of error. Now, sometimes when you run, what's a runtime error? Let me give you an example. If you're doing a division, a program, and you write a program to do division, and you divide a number by 0, what do you get? You get an infinite result. The computer can't handle that infinite result, so the program will blow up. The program will stop working. Right? That is an example of a runtime error. A runtime error is where the program stops working and it goes haywire because it can't do that processing. So if I divide that in, if I try to do something like that in a program, it simply does not, it just cannot work. The computer is going to go haywire and say, I can't process this. So that's an example of a runtime or execution error. And the last type of error you may have is what we call a semantic error, right? Which is an error where your program runs, it generates results, but your results are incorrect. So your program runs, it generates results, but your results are incorrect, right? So when we talk about debugging, right, we're talking about three types of errors that could happen: syntax errors, runtime errors, or what we call errors where your logic is not correct, right? And we'll go on to do more detailed examples of this. This is just these different stages in development of programs or a program. And we're going to look at examples of syntax errors. We're going to look at examples of runtime errors. We're going to go on to look at what we call logic errors, different types of errors at later on in the course. So again, if I go back to the top, when you look at designing a code, designing programs are designed, right? Programs are designed in a particular way. So if we go to the top and we go back to the top here, talk about the 5 steps, right? We talked about analyzing, we talked about designing, we're talking about code, we're talking about testing, we're talking about testing and debugging, which we just went through. And finally, the final step is to document the program. After we have done the testing and we get the program working, we have to document the program, because you remember I said at the top of this design, how to solve a problem, is that people coming after you need to make changes to the program. You may leave the organization, get a different job in a different organization. So as a result of that, what happens, you now have to document the program, so that makes life a little easier for somebody who is coming in later on. Any questions? Right? And when we look at document, right? Documentation, how to use the app. And people will get to understand how to use it. Now, most of you young kids, because of trial and error, you understand and figure out very quickly how to use an app. But if you are working, or if you're using systems that are in organizations, what is going to happen is going to be extremely difficult if you don't have documentation of how to use a particular system. Any questions? Everybody is good?
Yes, sir.
Okay. So how do we solve problems now? Everybody, could you just repeat that, please? Somebody says something just now. Okay. So
you have
let's
to
now
analyze
talk
the
about
problem.
the model, somebody said something about analyzing the problem. Could you just repeat that or put it in the chat? Because I didn't hear you. Do you want me to go over analyzing the problem, or is there a question on analyzing the problem? If you can just put it in the chat, I'll see it and then I can answer it. If you're breaking up.
So now I was answering the question, sir.
Okay, okay. Right? Okay, so let's move on. Right. So let's now look at the IPO model. Remember, we talked about different models that are used. You have different models that are used to do input, process, output, right? And the IPO model, we have 3 models. We have IPO, we have flow charting, and we have what? Pseudocode. Let me just go back up to that slide, and I will just bring it up for you again. When we talk about designing a program, we look at 3 methodologies to design a program. We look at pseudocode, we look at flow charting, and we look at IPO, right? Now, one of your assignments IPO model, and that will take place in week number 6. in more detail later on. So let's look at the IPO model, and then we can talk about your first assignment, which will happen in week number 6. So IPO means input, output, right? That is what IPO means: input, process, output. And as I said to you before, everything in solving up, taking an input, processing that input, and generating an output. Okay? Everything involves input, taking an input, processing that input, and generating an output. Okay. So now let's look at IPO. IPO is a concept that describes how a program takes input, performs operations on that data, and produces output. Right? And we gave you 2 examples of that before. And if you remember, I said the input is classified as something called data, the processing, and then the output is what we classify as information. And information is used for what? By businesses. It is used for decision making, right? So take, for example, if we have a payroll system, what's the primary function of the payroll system? Well, most of you will say, well, to pay people, and that's correct. So we have a payroll system with payroll programs, primary function to pay people. But management uses that payroll system to do what? To generate information to determine how much of our cost is being is payroll. So if I say I have 100 employees and my cost per month is $1 million, that $1 million is a cost to the business. So where do I get that cost from? I get that cost when I generate the payroll. The payroll is generating $1 million, which is going to be paid to the employees, but that $1 million is also a cost to my business, right? And I'm tying everything back for you, because at the end of the day, guys, information systems, programs, etc., are used by businesses to make decisions. So we talk about input, we talk about output, processing, and we talk about output. And the output is what management uses to make strategic decisions about a business. So if we talk about our tree, or sum and average, our input is the variables A, B, C. Our processing is the sum A plus B plus C. Our output is to print the sum and print the average. And that's what we want to do, right? And that is our IPO method. Now, our IPO method, right, is widely used to solve problems such as engineering problems, mathematical problems. So let's go back now. So if I ask you to create the IPO to solve for the sum and average of 3 numbers, again, this is the same thing I showed you at the beginning of the course. The sum, A is a variable, B is a variable, that is my input. I sum A, I sum A plus B plus C. I then find the average of A, I find the average, I find the average by sum, by dividing by 3. I then output the average and I output the sum. And that diagram there, or that table, is my IPO diagram for the average and sum of 3 numbers. So if I give you a question, right, then you will be expected to generate an IPO like what I've just showed you here for the average and sum of 3 numbers. Any questions? Again, just to reiterate, for you to understand this, for you to solve a problem, you have to understand the problem. Okay, guys, if you don't understand the problem, you can't solve the problem, right? And you'll just be going round and round in circles if you can't understand the problem. Any questions? Any questions?
So I guess like what questions would you ask to be able to solve the problem, to break it down into smaller parts? Like what are the best ways you would find to do that?
Somebody say something?
I'll put it in the chat too.
Yeah, the internet here is, as I said, if you put it in chat, and I'll stop sharing and put let's put it in chat. Okay, any questions so far? Anything else? Could the person who was just talking please raise their hand? So I can see who it is, please. The Kailash. It's ready. It's from. Um, Ms. Griffith, anybody question in the chat? Can I, right. So let's now look at a second example. Example of solving a problem using IPO. Convert the temperature from Fahrenheit to Celsius. So that's a simple example involving a simple mathematical calculation. So if I have the variable f, which is my input, I then decide to calculate the values. So centigrade is equal to Fahrenheit minus 32, multiplied by 5 divided by 9, right? The F is the temperature and C is the Fahrenheit. F is the temperature in Fahrenheit, C is the temperature in Celsius. So therefore, Fahrenheit from 32, multiply that by 5 and divide the result by 9, and I get my output. Similarly, the area, what do I need to do? So let me generate some discussion here before I'll stop sharing. If I have to, and you can put the answer. What questions would we use? Okay, Ms. Griffith is asking, what questions would we use to break the steps down? Okay, so let's take an example. If you have to find, let's take the example of finding the area of the rectangle. Right. So the first step is to analyze. So let's go back to the presentation. Is to analyze what the problem is in terms of input. So therefore, if I have to find the area of a rectangle, right? if I have to find the area of a rectangle, the first thing I will do, right, is first thing I will do is ask what are my inputs, right? That's the first thing I will ask myself. What are my inputs? So if you're asking the question, what you need to ask? So you're going to ask yourself, what are my inputs? Should my inputs be variable or should my inputs be constants? So these are the kind of questions you ask when you're looking at your inputs. Let's now look at your processing. Then you're going to ask yourself, how am I going to get from input to output? So let's take, for example, the area of the rectangle. How am I going to, if I have length, how am I going to get from length and breadth to area? Then I'm going to multiply length by breadth to get here. Then the third question I'm going to ask myself is, what do I need? What does the end user needs? He wants to see the length, he wants to see the breadth, he wants to see the area. So I need to output the length, I need to output the breadth, and I need to output those sets of information so that the end user can see what is required. Any questions? Does that answer your question, Ms. Griffith?
Yes, it does. Got it. Thank you.
Okay. Right. So therefore, again, we need to ask. So we need to ask for. Sometimes when you're doing something, you ask, okay, what do I need? What do I need is the inputs. How am I going to get to my end result? How am I going to reach to the area? Well, okay, how am I going to do it? I need to do some sort of mathematics. I need to, okay, multiply the length by the area. Okay, that I need. What do I need to give to the user in terms of output? I need to give to the user the area. So therefore, I need to multiply the length by the breadth to give the area. Okay, so that these are the types of questions you have. What logic I need to implement to get from the right, and the questions you have to ask yourself. Now, in some cases, it's very straightforward. In some cases, you have to do a bit of thinking. You have to figure out. There may be a roundabout way you have to get from A to B. You can't just get from A to B in a straight line. Okay? So it's important that you think about the solution. That's why I go back to, when I go back to this here, analyze the problem. You must analyze the problem, design the solution, implement the code, test the code, and document the code, right? Very important. Analyze the problem in terms of inputs, in terms of outputs, in terms of formula, in terms of variables, in terms of constants, right? Design the solution, implement the solution, test the solution, and document the solution. Okay? Any questions? So I'm going to go back to my IPO model now, and I say, find the area of a rectangle. Check. Okay, that's the first question. Find it. So let's take, what do I need to find the area? So the first question, what do I need to find the area of a rectangle? I need the length and I need the breadth. How am I going to use the length and the breadth? I'm going to multiply the length by the breadth to get the area. When I multiply the length by the breadth and I get the area, then I need to what? Output the area. Output the information to the end user. Right? If you go down, go to my next slide, it says variable L for length, variable B for breadth, area is equal to length by breadth, area is the output. Okay? So therefore, area is equal to length by breadth, and that is my output. So therefore, my IPO model for this is area length by breadth equal to area. So I'm outputting my area, that is for the end user. I'm processing the length by the breadth to get the area, and I'm putting in inputs in terms of L and B. L and B are examples of data, and A or area is examples of information, because the output is the information. The input is the data. Data is the raw course. Information is used by businesses to make strategic decisions. Very important. Information is used by businesses to make strategic. A variable A, and I've put in check to determine if the number divided by 2 has remained even or odd. So I'm asking the question. So the question really, what I've done here, I didn't put the question down for you. What I've done is just put the question, and I've said, okay, tell me, what does this question mean? Well, what it means basically is that I have a variable called A, and I want to determine whether that variable or that number is odd or even. So if I divide that number by 2, and I get a remainder of 0, that tells me it's what? It's even. If I divide 2 by 2, and I get a 0, which that means it's an even number. If I divide 4 by 2, I get a remainder of 0. That means it's even. If I divide 5 by 2, I will get a remainder of 1. That means it's what? It's an odd number. Everybody follows that? So if I give you this example, this is another way of doing this, odd and even numbers. So what I did here is I didn't give you a question for you. I've asked you what is the question, and I'm answering the question by saying the question is really checking see if you input a number, whether the number is odd or even. And in this case, how do you determine that by looking at the remainder. So if I put in a number like 7, 7 is an example of one odd number. When I divide 7 by 2, then it becomes what? Then I get a remainder of 1. Any questions? I'll stop there for now. Anybody have any questions? So, what have we learned in the first half of this lecture? We have learned
Sorry, sir.
the computer problem. But before we solve the problem, we have to figure out what the problem is. If we figure out what the problem is, then we can take steps to solve the problem. We can use different methodologies to solve the problem. We can use the IPO method, we can use the pseudocode method, we can use the flowcharting method. Right? We have looked at examples of using the IPO method, whereby it requires three components: input, process, output. The input The process is the methodology. The output is sent to the end user. Somebody asked the question, how do we identify what is needed for different stages? So therefore, the analysis stage or the stage to understand the problem is, what are my inputs? What do I think here, based on the problem, what do I think my input should be? How am I going to get to the outputs? What do I think the user is looking for in terms of outputs? Now, and I'm just going to harp a little bit on this Griffith question. Sometimes you as the programmer or as the system analyst, you have to have a conversation with the user to find out what is. Because sometimes you may misinterpret the user requirements. So you may ask the question to the end user, what do you want as your output? Because sometimes when they give you a scenario, you may not be clear. They may not be even clear of what they want. So it's imperative that using the input, process, output, you and the end user work out what is required. Because many times when I was a young programmer working at TSTT, right, back in the I wouldn't say how long, in the 1980s and 1990s, many times people would come to send a request for us, and we don't understand the request. We don't understand what the output is. So we have to go back to the end user to determine what the output is. And based on what the end user requires. Because sometimes you get it wrong, and sometimes you will get it wrong. And the key is when you get it wrong, what we'll do, we're going to take a short break just now, right? And then we're going to look at the second methodology, which is pseudocode. And another methodology, particular problem. So we talk about IPO. We're going to look at something called pseudocode, and then we're going to look at flow charts. And that will bring us to the end of the lecture today. And then next week, we'll continue. We'll start with structured programming involving the use of if statements, and then we look at repetition. And we look at them. Once we do both of them, we then look at programming examples. And once we finish that, we then actually write programs. Now, I have a question for you guys. As we talk about programs, and this course is going to involve some programming. How many of you have computers at home? And how many of you have access to a compiler so that you can execute C++ programs? Because your final assignment may be a programming assignment. And secondly, in the exam, you are given snippets of what the code is. So it's imperative that you have, I'm hoping that you have a laptop or some device like a tablet where you can a C++ compiler or an interpreter and test the programs for your own benefit. You guys follow what I'm saying? Anybody doesn't have a laptop? And do people have access to a C++ compiler? So I start with this. Let me see who I can start with. Anybody wants to start? Do you have a C++ anyway? Do you have a laptop at home or a device that could install a C++ compiler?
Yes, sir.
So, Mr. Douglas, I'll start with you. Do you have anything like that?
Yes, sir.
Okay, you have. Okay, great. So people understand what I'm talking about. So because if you don't have it, then we may have to make arrangements for you to come at Roy Tech, and I'll come and help you, advise you to run the program and to test the program. If you have it at home, it makes life a lot easier for you. You don't have to come in and do anything like that. So again, it makes life a lot easier for everybody. Thank you for that, Mr. Douglas. Okay, now, one more thing. I'm trying my best to make this as interactive as possible with you students so that it's not one-way traffic where I just sit here and lecture and lecture and lecture. Well, I mean, what I want you to do is be a little interactive. If you have any questions, like Ms. Griffith or anybody, please feel free to ask. I want to make the class as interactive. I want you to understand that when you finish this course and you leave this organization, you go out into the work, you get an understanding of how it is going to be in the IT world, as opposed to when you go out there, it's basically a sticker shock to you. So I want you to understand basically how things are going to be. It's not going to be like the classroom. It's going to be where you're working with teams, you're working with people, you're going to have to deliver on deliverables, especially in the programming space. And you need to consult with the end user because you are developing programs for the end user in mind. That's very important. You're not developing the program for you. You're developing the program for the organization. You're developing the program for the program in such a way that if somebody comes after you, that person has the ability now to make changes, and that changes to those programs should be seamless. Otherwise, it is going to cost the organization significantly in terms of time and in terms of money, because the person who has to change the program has to now understand what you have done. And if there's no documentation, that could be for an eternity. And not only that, the person who is making change could make errors. So that's why it's very important in the design of a program. Okay, any questions? Okay, well, it's 10:30, and I think I've spoken for the last hour and a half and a little more than that, right? So what I'm going to do, I'm going to give you guys a 15-minute break, right? So that you can stretch your legs. Unfortunately, go to the bathroom, do what you have to do, and then we'll rejoin at 10:45, right? You can stay logged in, right? And we will rejoin at 10:45, and we'll continue with the second half of the lecture where we're talking about pseudocode. So before we go, anybody has any questions? What I'm going to do, I just spoke to the people here at Roytech. I'm going to try to use another internet connection. Hopefully it will be a little better and a little faster. Okay? So I will log off for a little while and then I'll come back in with that new internet connection. If anybody has any questions, please let me know. Okay? Okay. Need to access C. Okay, somebody's telling me, and I'm seeing a few. Okay. Let me just try to answer some of these questions. Need to access a C++ compiler. I will try to figure out where's the best way to get one. I think Jewel, you asked that question. Ms. Griffith says that I have a Mac but no compiler, and some people are saying they don't have. Somebody says no, sir. I'm not sure what was meant by that, and I will look into it though. All right, so yes, you need to have a compiler, guys, right? That is very important because when you write your programs, you have to what I would like you to do is write your programs and test them. And when you move on to different levels in the course, you will have to write programs. I think some of you may be doing 103, right? And 103 involves the use of writing programs. So you will need a machine and you will need a compiler to execute those programs, right? So I'm happy to advise you guys of what you need. Maybe we can chat maybe one-on-one after the course or after the lecture. Those of you who want to hang back and we could chat about what is needed, but it's important that you get, for those of you who have laptops, you get a compiler so that you can use the compiler to generate, so that you could test your code when you develop your code. Very important. Okay, guys, anybody has any questions? Okay, when we come back, I'd just like you to do one favor for me. I see we have 14, but 13 people in the course. 1, 2, 3, 3 and 4, 7, 7 and 4 is 11, and 2, 13. Right, what I would just like you to do, obviously I introduced myself at the beginning of the course. I would like you to introduce yourself so I know who you are, right? Secondly, and let me be clear, I will be asking you questions, but the questions I will be asking is for you to, not to make you feel any way or something, it's just to generate a bit of interactiveness to the course, as opposed to just I teaching and I lecturing for an hour and a half. I just want to make sure that you understand what's going on. Questions, as I said, feel free. I'm going to give you guys a document about the course later on, and I want you to have a look at it, because it's very important, and I will have my number on the course. So if you have any questions, feel free to call me or send me an email. My preferred option is send me and I will respond to you. I'm going to try to help you as much as possible so that you pass this course. That is the objective, for you to understand and for you to pass the course. So I think I've spoken a lot for the last hour and a half. We will take a break now and then we'll come back at it's 10:35 approximately. So we'll come back at 10 to 11. Anybody has any questions before we go? Take a break and we come back. Okay? All right, guys. Anybody has any questions before we go?
No questions yet, sir.
Okay, everything is clear. Everything is clear, Ms. Griffin.
I would say clear, yes. I think we just kind of waiting for the whole thing to be able to ask the full questions that we need to. Like we're following, I'm following so far. I don't have any, besides the question I asked, any major questions at the moment.
Okay, you don't have any major questions. Okay, that's great. All right, guys. So I'll see you back in 15 minutes. Right? Thank you. Hi guys, is anybody hearing me? I've just changed internet, so I'm hoping it's a little better. Anybody hearing me?
Yes, sir.
Is it better now?
Yes, sir.
Mr. Lewis? It's better?
Yes,
Yeah.
yes, yes,
Okay.
yes, I'm
Change the
better.
internet connection, so I think it's a, yeah, yeah. Okay, it's 10:50, so let's start again. So what I'm going to do, I'm going to share this with you guys. I assume everybody's seeing my screen. Just give me a thumbs up, or just one person, please. Just tell me that you're seeing my screen. All right. Anybody? Hello?
Yes, sir.
Yes,
Seeing
sir.
the screen, right? Okay, great. Thank you. Right. Okay. So this is the course outline. So let's look at the course. It's two, right? So this is the course name. It's an online course. I'm also lecturing at 5 o'clock on Friday as well. So that's me. Um, if you have any questions, please feel free to email me or call me, right? I will answer. I'll try my best, or leave a voicemail if I can, if you don't hear from me, right? I will try my best to return the call. Ideally, if you send me an email, I can respond to you and provide you with an answer, right? Please, if you have any questions, if you don't understand something, if you have a problem with how to get a compiler, you just need some advice on the equipment, let me know. I could point you in the right direction. Okay? That's that. Now, talk about mission, learn, right. Okay, so learning outcomes, which is very important. Describe how to approach a computer, which we started today, right? Describe the fundamentals of computer programming. That is how to add the different steps in solving a problem. We talked about IPO model, and we are going to talk about pseudocode and flow charting, because we talked about the three methodologies in solving a problem: flow charts, pseudocode, right? And then we're going to start to look at later on the importance of structured programming, differentiation between algorithms, pseudocode, program code, arrays and modules, testing algorithms, converting pseudocode into programming languages, right? Because remember I said to you that 80% of the work is done off the computer. That 80% is where you design your logic, you design what your inputs are, you design your processing methodology, you design your output, you ask the questions, what do I need for inputs? How am I going to get my outputs? Is that the desired output for the end user? Right? So it's important. These are your learning outcomes. If you have any questions based on this, let me know. So that if you notice, what we have done thus far is to looking at the slides, you can see how I've structurally broken it up, understanding the approach, identifying the steps, talking about IPOs, talking about flowcharts, talking about pseudocode, talking about inputs, talking about processing, talking about output. We'll go in later on to program development. I said to you, it's imperative that you have a compiler so that you can develop your code, right? Okay? Now, as I said to you, some of you may be doing a course called 103, which is Introduction to Programming Code. This is the precursor to this. So therefore, you will do a little bit of coding. Hence the reason for 103, you will need your compiler to test your programs and develop your programs. Okay, guys? Right? The textbook recommended is A Simple Design by Leslie Ann Robinson. Okay? Now, this is important, right? This is your activity charts. Now, you are going to be given two assignments. One 6 and the other in week 9. Week 6 is going to be an IPO chart, right? Where it's going to give you a scenario where you can either use an IPO chart, whether you can use a flow chart, pseudocode, whatever, right? And then the other one is going to be a little more difficult, which is going to be using selection controls, arrays, etc. So you can either use a flow chart, IPO chart, etc. The first one is going to be pretty simple. The other one is going to be a little more complex. So you're going to have a week. You're going to be given the assignment, and you're going to have at least the assignment. Okay? It is not going to be a programming assignment. It's going to be a desk assignment, a hard copy assignment. Your exam is 50% of your final exam. So 50% plus 15 and 15 is 80%. Collaboration with peers to write algorithms or solutions, right? Sharing solutions in class. Now, this is where it's important, guys. Interactiveness in the class. If I ask you a question, okay, let me be clear, right? And I want to be clear on this. When I ask you a question, it's not to pick on you or to embarrass you or to, okay? I want to be clear on this. It's for you to, for us to have a bit of interaction, for me to make sure that I'm getting through to you, that you are understanding what I'm talking about. So let me be clear. There's no fear of anything. All I want to do is make sure that you understand what I'm talking about. That's the objective. Okay, guys? All right? We are all big people here, and I'm just wanting to make sure that you understand. Okay? And then finally, there will be an in-class assessment whereby I will give you an assessment. You will then do the assessment, and you will then, it may be more a written assessment. It's like a quiz, right? Where I will give it to you, and you will then respond to me. I will share the quiz. You will type in your answers. It will be a session, maybe an hour and a half, right? It's like a quiz. You then type it up, and you give me the answers. It's open book, so it's based on your knowledge, okay? I won't expect people to be opening a textbook or Googling it and that kind of thing when I give you. I expect a level of honesty that people will do, you know what I mean? All right? Any questions? So therefore, these things constitute your 100%, and this is your grading. This is what you're going to get. You're going to get grades from A+ right up to F. Okay. Any questions on this? There is a folder called class materials, which I think you guys have access to, and this is in that folder. I've already uploaded it. I also uploaded, right, the lecture for today, all 40 slides, right, the file for today. So you have that as well under class material. If people can't get them, just let me know. Send me an email, and I will send these slides and this to you via email. No drama with me. I will do that. If you don't have access to that shared folder. All right. Anybody has any questions with respect to the course outline? Any questions, guys? We good at the course outline. Everybody understand what the course is made up of and what we have to do, right? 30%, 50%, 10%, 10%, and when the different things are due. Okay? One more thing, I'll just reiterate this. It will be very good if you get a compiler, right, to develop your code. It will not only help you with 102, but it will help you with 103 and other second year courses like databases and that kind of thing. So if you have any questions, let me know. Good?
Yes, sir.
Stop sharing, and we good on this, right? Everybody good? Okay, so let's now move on to pseudocode. Let's give me a thumbs up if everybody's seeing my screen on pseudocode. Just one person, please. Anybody? Mr. Lois, are you seeing my screen?
Yes, sir.
Okay, brilliant. Okay, so let's talk about pseudocode. We talked about before input-output processing, or IPO, or input-output model, which we described. So there are three models we have to look at: input-output, flowcharting, and pseudocode. Pseudocode is a bit different to input-output. Pseudocode is basically a technique that is used to describe steps in solving a problem. Right. So it's just a different methodology. Some people like to use IPO. Some people like to use flowcharts, the more artistically inclined of us. Some of us like to use pseudocode. A lot of people like to use pseudocode because it's basically English writing. So you're developing your logic using English, using your native tongue. So let's look at, and I said before, pseudocode is a technique used to describe the distinct steps of an algorithm. So basically, a pseudocode is a stepwise solution of a particular problem. Right. Let's talk about now. The best way to learn these things is to get into it and do an example. All right? Let's now look. So, say to you, find the sum average of three numbers, which we did. We did the IPO of that. How am I going to do that in pseudocode? Okay, what do I need to find the sum and average of three numbers? I need to input three variables, A, B, and C. I then need to sum A, B, C. I then need to find the average of A, B, C. I then need to output the sum and average. So this is pseudocode. Pseudocode is using the English type words. It's using basically a step-by-step solution to solve the problem. So for example, and we go back to Ms. Griffin, if I ask you to find the sum and average of three numbers, what do I need? I need to input three numbers. I need to input A, I need to input B, and I need to input C. I need to sum A plus B plus C. I need to find the average of A of the sum by dividing the sum by 3. And then I need to print sum and I need to print the average. So this is the pseudocode, right? Now, if you look, I've said A, B, C are variables. Sum is a variable. Average is a variable because A, B, and C can take different numbers. A variable is a construct that can take different values. Now, what's the opposite of a variable? The opposite of a variable is a constant. So if I say 2, 5, and 7, those are constants. If I find the average of them and the sum of them, they will never change. While if I use A, B, and C, I can put in any numbers that I want and it will find the average and sum. As opposed to, right, as opposed to 2, which will just find the sum and average of those three numbers. Everybody understands the difference between variables and constants? And from your O-level, from your CSEC maths, etc., right? You should know in mathematics there are variables. Variables are numbers that can change. Constants are numbers that remain the same. Any questions? Okay, so if I give you a second example, convert temperature from Fahrenheit to Celsius. You know, if you're looking at it, what is the temperature outside today? You can either have the temperature in Fahrenheit. Fahrenheit we used to use in the 1970s, 1980s. That was changed because the European method of temperature is Celsius or centigrade. In the olden days, it was Fahrenheit. So if you go to certain European countries, they do it, sorry, the Americans use Celsius. In the UK, sometimes they tell you the degrees in Fahrenheit still. So if you want to compare, if you want to find, if somebody says, okay, well, it's 69 degrees Fahrenheit, and you want to convert it to Celsius to see, because some of you may operate on Celsius, to convert to Celsius, let's see which Celsius value equal the Fahrenheit input minus 32. Then we multiply that result by 5 and divide it by 9. We will then print the temperature in Fahrenheit, and then we'll print the temperature in Celsius. Okay? So that is an example of pseudocode. Pseudocode is a step-by-step solution to solving a problem, right? So it allows you as the end user to create a step-by-step solution. You can have 100 steps, you can have 300 steps, it doesn't matter. These are just simple examples of using pseudocode to solve a particular problem. We use the IPO to solve the average and the Fahrenheit solution in the previous slides. Now we are using pseudocode to solve the same problem. Deviating really, we are looking at different methodologies to solve the same problem. We talked about pseudocode, and now previously we talked about IPO. Any questions? So, pseudocode. Let's do another and more difficult example. These are problems using sequencing to solve a problem. So let's talk about this example. A computer repair shop charges $100 per hour for labor plus parts, plus the cost of any parts used in a repair shop. However, the minimum charge for any job is $150. Prompt for the number of hours worked and the cost of parts, which could be zero, and print the charge of the job. Now, we have two variables here. We have what? The cost of labor, and we have the cost of parts. Everybody agree with me? We have the cost of, because if you take your computer to fix, you want, okay, your computer has a problem, you take it to the whiz to fix. So the guy at the whiz says, hey, we could fix this laptop for you. We're going to charge you $100 per hour, plus we're going to charge you for any parts that we put in. So if you have to put in a condenser, if you have to put in a new drive, whatever. However, we are going to charge you a minimum of $150. If we didn't have to do nothing to your PC, and all we had to do was to clean it up and it working because it had some dust in it, we're still going to charge you $150. So the minimum you're going to pay is $150. However, if it is that your computer needs parts and labor, it's going to be charged on a pro rata basis. So let's see how we're going to do this. Let's write the pseudocode. So the first thing I'm going to do is find out how long is it going to take for my laptop to be fixed. So if it takes H is a variable. H is the number of hours. P is the cost of the parts. Right. So if I calculated the charge, right? The charge is the number, if I say the number of hours worked by 100 took 3 hours on the laptop. So 3 by 100 plus the cost of the parts. And the cost of the parts is another $50. So therefore, and it's variables. So we're using different variables. So 300 for 3 hours plus $50 gives me $350. But I have a minimum of $150. So if, let's go back, if the charge is less than 150, then set the charge to 150, right? Then print the charge. So if, when I calculate, it's 3 hours plus $50 per parts, that means it's 350. Is the charge less than 150? No, right? Then the charge is 350. So I will print 350. If, let's take this back a bit now. If the number of hours worked is 0 and the cost of parts is 0 because I didn't do any work, or the number, let's change it. The number of hours worked is 1 and the cost of parts is 25. So therefore that changes, that's $125. When I go to step 4, it says if the charge is less than 150, then set the charge to 150. So if it is 125 is less than 150, I will print 150. And this is where we have introduced now something called a conditional statement, which is what we call step 4, an if statement. Let's go it back. Let's do it over. Let's go back to the problem. A computer repair shop charges $100 per hour for labor plus the cost of any parts used in repair. However, the minimum charge for any job is $150. Prompt for the number of hours and the cost of parts, which could be 0, and print the charge. So let's assume we use 1 hour and it was just to clean it out, and we didn't use any parts. So therefore, H is 1, the cost of parts is 0. So 1 by 100 gives me 100 plus 0, so the total charge is $100. But if the charge is less than 150, then set the charge to 150. So therefore, we will be setting the charge to 1. But the charge is minimum of $150. Let's change it up a little bit. Let's assume H is 3 and the parts, the cost of the parts is $75. So if the number of hours is 3 by 100, which is 300, plus 75, that gives me $375. If the charge is less than 150, then set the charge to 150. The charge is not less than 150. It is 375. I will print a charge of 375. We have now introduced something called a condition statement in step 4, which says if the charge is less than 150, then we do the then condition. So therefore, that statement has a true or false. If it is true, we set it to 150. If it is false, we go to step 5. So this is basically pseudocode a problem. It is very similar to that of IPO because all IPO is different really is that the IPO has a what? Boxes for input, boxes for processing, boxes for output. This is more of a logical flow of how we are going to solve a problem. So we have looked at what? 2 things so far. We have looked at pseudocode and we have looked at what? IPO. Any questions on pseudocode? Now we're going to it in more detail, but this is an overview of pseudocode and how pseudocode works. Anybody has questions? Are we good? Okay, let's then move on now to flowcharts. Remember I said to you that you can solve a problem using any of 3 methodologies: IPO, at flowcharts, right? And we talked about what is a flowchart. A flowchart is a diagrammatical representation of a computer program, algorithm, or system using a set of steps and using a set of steps and shapes to illustrate a program. So before we start to draw any flowcharts, right, we need to understand what it is. It shows the logic of an algorithm. It emphasizes the steps. It shows how the data flows through the program. Now, with a flowchart, as the name depicts, a flowchart has symbols, right? So we have to understand what the symbols represent. And then once we understand the symbol, then we can do our favorite examples. Sum and average, converting Fahrenheit to centigrade, finding the area of a rectangle. All these simple examples that we have did with the IPO, we're going to repeat it using the flowchart. Okay? So, look at the various symbols that we use. The oval represents the start and the beginning of a flowchart. The parallelogram is used to denote an input. Like if you have to input A, input B, input A, B, C, that is represented by a parallelogram. The rectangle denotes a process. So if you have to find the area, so the area or the sum is equal to A plus B plus C, that's a process. So S is equal to A plus B plus C, that's a process. So that is being depicted by a rectangle. The diamond denotes an if statement, and the hybrid denotes an output operation, and the line denotes the direction of flow. So very simple. So therefore we talk about denotes the beginning and end, denotes an input operation, denotes an output, denotes a if statement. Basic symbols that are being used for an operation. No issues there. So all you need to do is remember what the different symbols are and use the symbols accordingly when you're designing a flowchart. So let's go. As I said, I normally say to you, examples are the best teachers. So let's find the sum and average of somebody's grade. So if it is that you have 4 assignments, assignment 1, assignment 2, assignment 3, assignment 4. Right. So we have to find the average of those 4 assignments to get your grade. So if we sum M1 plus M3 plus M4, that is basically the average. M1 plus M2 plus M3 plus M4 is the sum. M1 plus M2 plus M3 plus M4 divided by 4 is your average. You say if the average of the student is less than 50, then the student has deemed to fail the course. If the average is greater than 50, then the student has been deemed to have passed the course. Right? So let's look at it. If you notice, the oval indicates the start of the question. Then we input M1, 3, M4. We find the sum and average of M1 to M4. We then check to see if the value of grade is greater than 50 or less than 50. If the value is less than 50, and then we will print that the person has failed the course. If the value is greater than 50, right, then it will print that the person has passed. Right? So you have a decision box there. In the middle, you have a decision box. The decision box determines whether you pass or fail. Pass means that you have an amount or a grade of greater than 50. Greater than or equal to 50. If you have something less than 50, you would have been deemed to have failed the course. Okay? Any questions? So this is a simple example of using a flowchart. Again, if I go back to slide 30, we are using the symbols that are used in a flow. What we have done is taken a problem and try to solve the problem. We haven't reached coding as yet, guys. We are on the stage of trying to use our acumen to solve the problem. We'll get into coding just now, but as this, if you can't solve the problem from analyzing, can't solve the problem by coding it. So there are steps to solve the problem. Okay, that's example one. Okay. Example two, my favorite example. Write an algorithm and draw a flowchart to convert the length in feet to centimeters. Okay? So, length is in feet. So you input the length, you calculate the length in centimeters by multiplying the length that you input by 30. Okay? And then you print the result in centimeters. So basically, whatever, if you say you put in the length in feet, right, and you put in is 3 feet, right, and you want to convert that to centimeters, you multiply the length by 30, so you get 90, and therefore that 90 gives. So if you decide to draw that, right, so you input, you input the length, which is L in feet. You multiply L by 30, right? And as a result of multiplying L by 30, you get the outcome, which is LCM, length in centimeters. You print the value in centimeters, and then you stop. Simple, using a flowchart. Similarly, if you have to find the area, your inputs will be the length and the breadth. Your calculation will be the area, which is going to be the length by the breadth, the area, and then you stop. So flowcharting is similar to that of IPO, similar to that of pseudocode, but just a different methodology that one could use to solve a particular problem. Any questions? Okay, let's now look at example 3. Okay, my favorite example. Write an algorithm and draw a flowchart that will read 2 sides of a rectangle and calculate its area. All right, what do we need? Let me just ask a question again. It's just to throw it out there, and let's have a little interaction now, and let's see who's following. Tell me, anybody, just tell me, what is going to be my inputs? Anybody?
So the width and the length of the rectangle.
Correct. So the length and the breadth will be my input. That's absolutely correct. What is going to be my, so that's going to be my inputs, right? What is going to be my processing? Anybody?
Multiplying L by with W. Length,
Right.
and, length and width. Yeah.
Right, to get the area. Correct. And then what is going to be my output? Anybody?
Area.
Okay, so the area is going to be my output. So let's see if it is that we are correct. Right. let's go to the slide. So, correct? Everybody was understanding that very good. So we're going to start. We're going to input our length and breadth, or length and width, right? We're going to multiply the length by the breadth, the area, and stop. But that's great. Now, any questions? Now, you're gonna come to do some assignments. You're gonna have a few assignments to look at when you for homework, right? So basically, this is the steps. No issues, no drama. Everything is easy, like Sunday morning. Right. So basically, a flowchart is a graph used to depict or show a step-by-step solution using symbols, which represents a task. Right? And I'll go back to the third one. If you notice, each of the symbols are connected by a line. The line connects the symbols, they link each other, and they generate a diagrammatic representation of the solution to the problem. It represents a diagrammatic representation of the solution to the problem. Okay? We go to third one. The symbols used consist of geometrical shapes that are connected by flowcharts. It is an alternative to using flowchart pseudocoding, whereas a pseudocode is a descriptive, it's verbal, a flowchart is graphical in nature. So let's look at that. The IPO is more table-like. The pseudocode is more English-like. The flowchart is more what? Graphical in nature. That means it provides you with a picture. So you as an assignment to use, and if you go back to the sheet that I said, the course outline, it tells you, when I give you an assignment, you can use an IPO, you can use a what? A flowchart, you can use a pseudocode. It is what? Based on the preference of the who? The end user. It is based on the preference of the end user. Who is the end user? The end user is you guys, right? You guys could choose which methodology you want, which one is best for you, which is best suited for you, which one you understand better, right? Nobody's going to tell you that you have to use A, B, or C unless it is specifically stated in the question. Okay, questions? Thoughts on flowcharts? Now, we will go in now. What I will do as we go into more complex questions, as we go in to learn about things like selection, as we go into learn things about repetition, you are going to come into to see more complex flowcharts. Right? Now, each of these, this is an example, this algorithm, finding the area of a rectangle is something called sequencing. What is sequencing? Sequencing means that you have a step-by-step flow of the solution. And you need to make a note of this, guys. Every computer program could be solved using three things, and I will put that in my slides later on. One is sequencing, two is selection, and three is repetition. But we'll come to that. So this is an example because everything follows one after the other, right? It is called sequencing. Everything follows one after the other. It is a sequence. Okay. So what as part of the assignment, just for if you want, you can look at, as I said, you have these I'm putting little assignments that you want. If you want, it's very simple, right? Create an algorithm and a flowchart that accepts two numbers and then displays the bigger one. So how can I check to see if one number is bigger than the other? Let's think outside the box. What am I going to do? If I have two numbers, A and B, how do I know if A is greater than B? Answer. Sorry. Anybody knows? Anybody? Anybody want to hazard, I guess? What I
You mean
can
if-
do is, go ahead, sorry.
No, I was just
What
asking
you
if you
map
mean if
out?
you if you were to denote it on your flow chart, for example, is what you mean?
No, what I'm asking, if you
Just
if you
in
can
general.
solve it, if you can solve it, that's what I'm asking you to solve it.
Oh, well, you'd look at both of them and see which one is larger. So if A is greater than B, you'd be able to
Right,
see if one bigger than the other. If B is greater than A, then you'd know.
right.
Just
So
by
that's
simply
very
looking
good.
at it.
So therefore, what you're going to do, you're going to input A and B, right? Then you're going to make a comparison. Then let's do it in our head step by step, right? And then you could put in you could do it in either IPO or flowcharted or pseudocode. So let's think about it. First thing I'm going to do is input A and B. We all agree? A and B are going to be my variables. Compare now and say if A is greater than B. If A is greater than B, then what? Then A is bigger. Correct?
Yes, sir.
Everybody agrees? Right? If, so then that's one statement I can have. Then I can have another if. Or I could say, if I say if A is greater than B, right, then print A. So that's my second step. If A is greater than B, print A, because A is the bigger number. And then I can go to step 3. If that condition fails, I guess what? Print B. You follow? It's just like this one here. I go back. Right? If, then else. If A is greater than B, then print A, else print B. I can do it that way, or I can do it another way where, remember I had this step 4. If the charge is less than 150, then set the charge to 150. But if the charge is greater than 150, it will bypass this statement. So if I can say if A is greater than B, then print A. And if it is not, then it will bypass and print B. Everybody follows that? So I can input my two variables, which is A and B. I then compare them. I compare A with B. I say if A is greater than B, then print A. Or I can then make another test. If B is greater than A, print B. Or if A is greater than B, print A. And then I can then, if that statement fails, I then print B. So there are a number of ways you can do it. So one of my assignments for you guys is to try it. Try it. Use any methodology you want, and then you come back to me and show me what you have done as an assignment. Everybody's up for that? Any questions with that? Anybody has any concerns, or do you want me to do it for you? I will come with a solution next day, obviously, but I didn't want to bring it. I didn't want to bring a solution and give. I wanted you to just have a stab at it. What will you guys have a stab at it?
Yes, sir.
Yes, sir.
right? Is it difficult or is it something that you feel that you can do? Okay, we're gonna try it. And we're gonna see, right? Okay, this one. Calculate, create an algorithm and flow chart that will compute the area of a circle. Right. What is the area of a circle? Pi r squared, right? Correct? Pi is what? Pi is a constant. So pi is 3.14, right, guys? R is the radius. Okay? So R is our variable. So we will input R. We will then calculate the circumference by saying 3.14 by R, and then we will, sorry, the area, sorry, 3.14 by R, and then we will output the area. That makes sense? Any questions? Could we do that as a flow chart? It's very similar. It is very similar to the rectangle example. Okay?
Yes, sir.
Right. Assignment, the last one I will not give you to do. I will do that one for you at some point in time, right? Or as we develop more into the course, I will look at doing that for you later on. But I want you to try to do number 37 and number 38. If they're quite simple, leave 39 and 40 for me. I will do that for you. But if you want, given that you're starting, you've seen how to do things, you understand about IPOs, you understand about pseudocode, you understand about flow charting, right? Or when you've started to look at it, you can take a stab of it, right? As you get more and more into the lectures, as you get to have more and more understanding of the course, you will have a better understanding of how to deal with flow charting, how to deal with IPOs, how to deal with pseudocode. So let's just go back a little bit. Let's go back to the top and talk about basic concepts in solving problems. And I think, let me go to this slide. This is the slide I'm looking at. Developing detailed logic using tools such as pseudocode, flow charting, and IPO. So that's what we basically did today, trying to solve problems using these different methodologies, using IPOs, using flowcharts, using pseudocode. That is what we have done. We went through in detail. What is a flowchart? What's an IPO? What's pseudocode? How we can do it. We looked at the same set of examples over and over, and hopefully you have understood what I've said today in the lecture, and you have now a basic understanding. And what I want you to have is a basic understanding today. Today is the first lecture. All you need to do is to have a basic understanding of how this thing works. Nothing more, nothing less. Right? As we go on, you will get more familiar. You will then have more confidence. You will ask questions, and then we can be able now to talk about how we get this thing done. Okay, so I'm going to stop there for a few minutes and ask people what are their thoughts, if they have any questions, if they have anything that they don't understand, if you want me just to go over some of the slides for you, right? I'm just going to go back over item number, which talks about how to solve a computer problem. And we talk about analyzing the problem, designing the problem, implementing, testing, and debugging. Very important, right? And how do we analyze a problem? We analyze a problem by using flowcharts, IPOs, and pseudocodes, right? Okay. When we look at step 3, in terms of writing programs, that is where we get a bit more difficult, and we have to understand how to write programs using C++. As I said to you before, let me ask some questions. How many of you are doing 103 this semester? Everybody's doing 103?
No, sir.
All you guys are doing is 102.
Yes, for me.
Okay, well, everybody's doing, okay, so you're not doing 103. Okay, well, at least for now, you still need a compiler. If anybody's doing 103, or anybody's maybe repeating 103, you will need a compiler to do your work. Okay, so I think we have done, we've spent a lot of time. I have spoken a lot for the last 2 hours and 41 minutes, or 42 minutes, or 43 minutes, whichever you want to count. So I just need to understand, I just need to get to have a understanding of each of you guys, since our internet is much better. End of the course, end of the lecture, I just need to know who you are. And secondly, I have a stupid question, and please indulge me. This course is people from Sanford, from South only, or is it all of Roytech?
All of right.
Anybody answer?
I think.
All of Roytech. Okay, I thought it was San Fernando only. Oh, that was definitely not, that wasn't correct. Okay, so that's one, all of Roytech. And you guys are just doing 102 this year. You're not doing 103, right? What courses are you doing? Just 102? What computer courses are you doing?
For me, this semester it's 101 and 102.
Now, what is 101?
Intro to information systems.
Oh, intro to information systems, and this one intro to problem solving. Okay.
Yeah.
Cool. Okay. All right. I now understand what's happening. And then next year you will do, next semester you will do 103, because 102 is the prerequisite for 103, I believe. Okay? For both 101 and 102 are the prerequisites. Okay. So let's introduce yourself to me, because I have already done that. My name is Richard Farrell, and I am the lecturer for this course. For all 12 modules, I have science degree in computer science, maybe long before most of you were born. And I have an MBA in finance. So that's me. Could you guys just introduce yourself so that I know who is who? And then we will terminate it. We'll just ask if there's any questions. And don't forget, please go to the material site, and you will see the 14 slides from this lecture. So you can save it and for your review and go through it. And if you have any questions, please free to email me and I will respond. Okay, so let's start with you, Ms. Griffith, since you are closest to me.
I say, what specifically would you like me to?
Just tell me your name and okay, just tell me your name and where you went to school, and is this, and what, sorry, where you went to school, and what program you're doing. Sorry.
Okay, hi, my name is Crystal Griffith. I went to Deacon Martin Government Secondary, which is, I believe, Central now. It was a long time ago in my head. And I'm in the Addison program.
Okay. Ms. Duki?
Hi, my name is Saraduki. I went to Queens Royal College about 6 years ago, and I have some understanding and knowledge of programming. I did that for CXC.
Okay. Cool. Amir?
Yes, sir. My name is America, sir, and I went to school at Holy Cross College, and I am doing the ageism program.
Okay. Philip?
Yeah, my name is Daria Phillip. I went to Bishop's East and I'm doing the Edison program.
Okay. Mr. Douglas?
My name is Shaden Douglas. I went to Mokwapo East and I am doing the Addison.
Okay, cool. Dominic?
Yeah, good to see you. My name is Dominic Puso. I'm into aviation and I went to Trinity College East. I'm doing the Edison program.
Okay, cool. Mr. Lewis?
My name is Ruden Lewis and I attended Eldorado East Secondary School and I am doing the Addison program.
Okay. Mr. Foster? Foster?
Yeah, good day, sir. My name is Israel Foster. I went to Trinity College East and the program I'm doing is the Addison program.
Okay, great. Chelsea?
Good day. My name is Chelsea. I attended Northeastern College, that is in the East, and I'm doing Addison.
Northeastern is in Sandy Grande, yeah?
Yeah.
Yeah. I had a friend who went to school there and he went to university with me. That's a long time ago. And Hazel?
My name is Shama Hazel. I went to Corpus Christi College and I'm doing a design program.
Okay. And Joel?
Hi, I'm Jewel and I'm originally Sudan. So yeah,
Okay.
I'm doing Addison.
Okay, cool. And Frank?
Yes, sir. My name is Kala Frank. I went to St. Anthony's College and I'm doing the Addison program.
Okay, cool. All right. There's a few housekeeping announcements, guys. You don't have to call me sir. We don't have to be that formal. Just call me Richard. And if you're right, and if you have questions, feel free to ask. As I said before, any questions, and there are no stupid questions, right? We are all here to learn. If you have any questions, let me know, and I will try my best to answer you. Don't be afraid. If you don't want to ask a question in front of everybody, just email me. Email me, I will respond to you. All right? Okay, well, thank you very much, everyone, for this. We will start. Don't forget, could you guys just let me know whether somebody sent me a note telling me whether you guys got access to the flights, because they are up there in under material, course material. So when you get a few minutes, somebody please send me a note just telling me that you have access to the slides, so that if not, I'll find another way to get them to you. Okay, I want to make sure that okay. Again, you could
So
okay.
is that in Canvas or in Teams? Because I'm not sure where to look.